Good morning. Right. I'm sharing my screen with you. Can you see my screen?
Yes, sir.
Right. Last time we discussed about Lewis theory,
Yes, sir.
right? We discussed about the formation and properties of ionic compounds.
Yes.
Covalent also?
So only the ionic.
Only the ionic. We are done. Okay. And what is a covalent bond? The bond formed by
Sharing of
sharing of
electrons.
electrons. So if we talk about a molecule like carbon tetrachloride, right? The
Yes, sir.
central atom is a carbon. Rupashi, what is the atomic number of carbon?
Atomic number 6.
Atomic number is 6. All right. So, what is the number of, what is the electronic configuration of carbon?
Yes, sir. It's 1s2,
Hmm.
2s2, 2p2.
Okay. So, what is the valency of this carbon?
4.
4. That I'm
So,
showing by these 4 dots. We call it Lewis dot structure.
yes, sir.
Lewis dot structure. Similarly, other element is chlorine here, which is combining with it. Atomic number of chlorine,
17.
electronic configuration,
1s2, 2s2, 2p6, 3s2, 3p5.
so
Yeah.
we can write like this also,
Yes, sir.
right? When we can write like this, so what is the number of the valence electrons?
The number of valence electrons are 7.
7. And the Lewis dot structure for the chlorine is symbol, right?
Yes, sir.
And if I expand this 3p5, can I write here 3px2, 3py2, and 3pz1?
Yes, sir.
It means I have outermost shell electron like this, 3s2,
Yes,
3px2, 3py2, 3pz1. I have
yes, sir.
one unpaired electrons and I have 3 pair of electrons which are paired. So I will show here one unpaired electron and 3 pair of electrons like this.
Yes, sir.
Chlorine has 7 electron outermost shell. It is sharing with the one chlorine, one carbon. It is now making a bond like this. Am I clear?
Yes, sir.
So 1, 2, 3, 4, 5, 6, and one electron here sharing here. The chlorine is completing its octet by sharing electron with the carbon electron.
Yes, sir.
Okay. Now if you see the carbon has a 4 electron outermost shell, 1, 2, 3, 4. But sharing with the chlorine 1 electron, now its octet is also complete.
Yes, sir.
So according to the octet theory, only those elements are stable which have 8 electron outermost shell, they can make bond, right?
Yes, sir.
Right? They can make bond. So between carbon and chlorine, one single bond is formed
Yes, sir.
and such 4 single bonds are formed.
Yes, sir.
We call these are 4 single covalent bond. These are 4 single covalent bond. Am I clear?
Yes, sir.
Okay. Let us make it for fluorine molecule, F2.
Yes, sir.
Fluorine, atomic number,
9.
electronic configuration.
1s2, 2s2, 2p5.
So can I show the 7 electrons like this?
Yes, sir.
Okay. Another fluorine has also 7 electron with 1
Yes, sir.
unpaired. Now they share electrons with each other like this. So it is a F bond F.
Yes, sir.
And these are the electrons of the fluorine which are present in the outermost shell but they do not take part in bonding.
Hmm.
This is called as a lone pair of electrons.
Yes, sir.
And the pair of electron that is involved in bonding, this pair is called as a bond pair of electrons. So in every molecule, there may be some bond pair and some lone pair of electrons are there. Am I clear?
Yes, sir.
So between fluorine and fluorine, one single bond is formed. We call it single covalent bond.
Yes, sir.
We call it single covalent bond. Am I clear?
Yes, sir.
Similarly, if I talk about O2 molecule, O2, oxygen, atomic number
8.
8, electronic configuration
1s2, 2s2, 2p4.
1s2, 2s2, and 2p4. 1s2, 2s2, 2p4. Let us expand 2p. 2px2, 2py1, and 2pz1, right?
Yes, sir.
So these are the valence electrons, 6 electrons. So we say oxygen has a 2 unpaired electrons. These are the 2
Hmm.
unpaired electrons, and other 2 are the lone pairs which are not going to take part in bonding. Only these 2 electrons which are unpaired, they will be involved in bonding. I'm showing by a different color, right?
Yes, sir.
Got it. So second oxygen, 2 lone pairs are there, and these are the lone pairs. Bonding electrons make a double covalent bond. Octet of both of these elements are not complete. Can you see that?
Yes, sir.
By sharing electrons. So O
Yes, sir.
double bond O is formed. This is called as a lone pair of electrons, and these are called as a bond pair of
Bond.
electrons.
So are you saying something?
Yeah, please. No, you want to ask anything?
No, sir. I
Okay,
wasn't able to hear you after the
okay, okay.
bond pair.
Yeah. Any doubt till now?
No, sir.
Okay. It means I have a double covalent bond between two oxygen atoms.
Yes.
We call double covalent bond. Double covalent bond. After this, I have now N2 molecule. Nitrogen. Atomic number, Rupashi.
7.
Electronic configuration.
1s2, 2s2, 2p3.
Can I expand the 2p like this? 2px1, 2py1, 2pz1.
Yes, sir.
Only these unpaired electrons take part in bonding.
Yes, sir.
It means on this nitrogen, I have this pair as a lone pair and 3 electrons are there which are unpaired.
Yes, sir.
But in case of nitrogen, I will show like this. See here, they are going to make a triple covalent bond.
Yes, sir.
Okay.
Yes, sir.
So nitrogen, triple bond nitrogen with one lone pair on each oxygen atom, and these are three bond pairs.
Yes, sir.
So we say it's a triple covalent bond. Triple covalent bond. Am I clear?
Yes, sir.
Triple covalent bond. After this, we have, let it be water. The central atom is oxygen.
Yes, sir.
There are two lone pairs, and the two electrons are available for making bond.
Yes.
Hydrogen has only one electron outermost shell.
Yes, sir.
It is completing its duplet.
Yes, sir.
In case of the hydrogen, duplet is complete,
Yes, sir.
and oxygen is now completing its complete octet. Can you see that?
Yes, sir.
So this is the Lewis dot structure of the water. Can you try for ammonia, NH3?
Yes, sir. Yes, sir. Done.
Done.
So the central atom is nitrogen with one lone pair and then three single electrons. Each side one hydrogen with one electron.
Good.
Okay.
I can say single bond between nitrogen and oxygen,
Yes, sir.
and this is a lone pair.
Yes.
Am I clear?
Yes, sir.
Now, this is how this theory explain, right? The bonding. Now let us talk about the properties of covalent compounds. Number one property, they are soft. They are either gases or liquids
Hmm.
normally, right? But with exceptions are there, like we have a diamond that is solid, or graphite
Yes.
that is also solid. The certain exception cases are also there, but most of the substances are either gases or liquids. They have a low melting and boiling point normally, except for these,
Yes, sir.
right? They don't have any free electrons. All electrons are paired, so they have um, they are insulators. They don't conduct electricity. Right?
Yes, sir.
These are the properties of the covalent compounds. Any doubt till now?
No, sir.
No. No. Next. Next, write on limitations of octet theory. Number one, it does not explain the stability of a hypovalent compounds. What do you mean by the hypovalent compounds?
That means that the octet is not complete. No,
Yeah.
they don't have 8 electrons in
Okay.
the atoms.
Central atom does not have a complete octet.
Yes, sir.
Can you give me an example?
Uh, just a second. Mm,
See, BeCl2. The central atom element does not have a complete octet.
mm,
Does not have complete octet. So according to the theory, only those elements are stable in the compound form when they have a complete octet.
mm,
But here the boron is having incomplete octet. Can you see? It has only
mm.
6 electrons here.
Yes, sir.
Here we have only 4 electrons here.
Yes, sir.
So it does not explain the stability of the hypovalent compounds, right?
Yes, sir.
Practically they are stable.
So why are they stable? Why are they stable though?
Yeah. This theory cannot explain. I say this theory cannot explain. But other theory will tell. But this theory fails. That's what the limitation I'm talking about.
Okay, sir.
Hypervalent compound. It does not explain the stability of the hypervalent compounds. Hypervalent compounds are those in which central element has more than 8 electrons. For example, if I talk about the PCl5, phosphorus
Yes,
pentachloride,
yes,
atomic number of phosphorus is 15, right?
yes, sir.
And it has a 5 electrons outermost shell.
Yes, sir.
And if it combines the chlorine here, sharing complete octet. Got it now?
Yes, sir.
Sharing complete octet.
Yes, sir.
Sharing complete octet. Got it now?
Yes, sir.
But if you see the central element, phosphorus, that is having a 10 electrons.
Yes, sir.
10 electrons. It's a hypervalent compound. The theory does not explain why it is stable. Now talk about SF6. Can you make the structure of the SF6?
Yes, sir.
Sulfur atomic number 16.
Yes, sir. The octet of fluorine is complete, but sulfur has 12 electrons.
Yeah. So it does not explain the stability of such compounds which are hypervalent.
Yes, sir.
Number third limitation. It does not explain it does not explain the stability of, sorry, it does not explain the paramagnetic character. Paramagnetic character of oxygen. Right? What do you mean by the word paramagnetic?
So we did an atomic structure that they're the lone pair attraction or repulsion.
No, 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 not like this. So paramagnetic means here I have a magnet, and around this magnetic there is a magnetic field.
Mm.
Around this we have a magnetic field, right?
Mm.
In this magnetic field, if any substance, when it comes in the magnetic field, if it feels feebly attracted towards it, feebly attracted by magnetic field, feebly attracted by magnetic field, that substance is called paramagnetic. That substance is called paramagnetic. And for a substance to be paramagnetic, the molecule must have some unpaired electrons.
Mm.
If a molecule has some unpaired electrons, the molecule will be paramagnetic. Paramagnetic. Am I clear?
Yes, sir.
Unpaired electrons. The molecule having some unpaired electron. That is a paramagnetic. And now if you see the O2 molecule, I'm drawing the Lewis dot structure of O2 molecule. Right now we have done also, right?
Yes, sir.
Can you see that in this molecule we have upspin, downspin, upspin, downspin. All electrons are paired.
Yes, sir.
So if all electrons are paired, the molecule must be diamagnetic. Diamagnetic means repelled by magnetic field. Repelled by magnetic field.
Mm.
Right? But practically it is not repelled. It is practically paramagnetic. It is attracted by the magnetic field.
Mm.
So why it is so, it does not explain the property. Got it now?
Yes, sir.
Now, next. another property. This theory does not explain that when we make a covalent compound, how energy is decreased and how stability is achieved. During the covalent bond formation, how stability is achieved and how energy is decreased. That is not explaining. Am I clear?
Yes, sir.
Due to all these limitations, this theory is rejected. Am I clear?
Yes, sir.
Why are we rejecting this theory? Because of
Because
all
of all.
so many limitations I had discussed. It does not
Yes.
explain the hypervalent compound stability. It does not explain the hypervalent compound. It does not justify why oxygen is paramagnetic. It does not
Yes, sir.
explain the stability, how the stability is achieved while bonding the making a bond. So this theory has so many limitations. Another one more very important limitation. It does not explain the three-dimensional structure of the molecule. It does not explain the three-dimensional molecule must not be in one plane, right?
Yes, sir.
It must be having some three-dimensional structure. So this theory is rejected, right? Rupashi, how much have been discussed in your institute, like LN1 or something?
So we have just a second. We are doing the Lewis structure. So sir just told me a few formula for the formal chart, central atom, which one will be central atom, how
Okay,
to calculate.
okay. Means, they are behind us,
Yes, sir.
right? Okay. All the extra thing they have done is the formal charge, right?
Yes, sir.
Okay, that we'll discuss later. Don't
Yes.
worry about it.
And he gave the sir gave a little introduction about resonance. He said that he'll discuss in the next class, that is today.
Directly resonance without
We have
okay.
he said
Anyways,
that in the next class he will discuss
okay,
resonance.
fine, no problem. Now I'm talking about next theory now, right? On quantum theory of radiation, quantum theory of bonding, quantum theory of bonding. The basic idea about the quantum theory is, suppose we have an H2 molecule and I want to break the bond. Means I'm making the two H atom. I need to
Hmm.
provide some energy here, right?
Hmm.
Now
Yes.
think reverse. Bond formation. When the two atoms will come closer, make a bond, energy will be released.
Hmm.
Am I clear?
Yes, sir.
It means whenever the covalent bond is formed, the energy is released.
Hmm.
But let us explain how so. I'm drawing a graph between the energy and the distance between two atoms. Zero energy, positive energy, negative energy.
Hmm.
When the two atoms of hydrogen are at infinite distance away from each other, right? The energy
Yes.
between them is zero,
Huh.
but they are attracting each other, right? So they come closer. As they come closer, they lose energy, and when they come more closer and make a bond, in this case, what is happening? The electron of atom one is attracted toward nucleus of the second.
Hmm.
Now, if they come more close, what will happen?
They
there will
repel.
be inter-electronic repulsion and there will be inter-nuclear repulsions.
Hmm.
And due to that, the energy will further increase. It means what is happening is, see here, very important that I'm showing you right now is the energy zero, energy decreasing. This is the
Hmm.
energy when they have made bond. If they come more close, the energy will further increase.
Yes, sir.
Right. It means when they come, when they go, when they repel, they'll go away from each other.
Hmm.
Again, they will attract and come closer. It means a bond between H and H is not having fixed bond length. They are vibrating. They're coming closer and going away. They're coming closer and going away. They're coming closer and going away. It will
Yes,
keep
sir.
on happening. So we say
Yes.
they are undergoing. They are undergoing what?
Vibration. Vibrating.
Vibrations. Note down this graph.
Yes. Yes, sir.
Understood?
Yes, sir. So that means the its bond length would not be fixed.
No, no.
Acha.
Bond length is not fixed. Bond length is not fixed. Am I clear till now?
Yes, sir. Yes, sir.
So between two hydrogen atom, when they are making bonds, how many attractive forces are there?
Two attractive
Two attractive
forces.
forces are there. And how many repulsive forces are there?
Two repulsive forces.
So there is a balance. There is some balance is there, right?
But
Oh,
sir, if
oh,
the nucleus repel, that would be
that's
more
what I say.
powerful than
That's what I say. Due to the when the nuclear repel, the electron repel, there's repulsion,
yeah.
right? But electron of one attracting the nucleus of the another,
Hmm.
that brings attraction,
Yes, sir.
right? So there's
Yes.
a basically equilibrium between the two,
Yes, sir.
and that is also bringing the stability.
Yes, sir.
But now, if we talk about the helium molecule, does it explain the helium molecule? Possible to make a helium molecule? You know that helium is a noble gas, right?
Yes, sir. It's not. It should not be possible.
It, but question is, this theory explain this?
No,
How?
because नहीं मतलब Lewis नहीं करेगा. Just a second. Mm, This theory, I'm not sure.
Okay. in a nucleus of one atom, I have a two proton, two neutron, and outside I have a two electrons. With the another atom, again I have a two proton, two neutron, and two electrons. Can you tell me how many attractive forces are there?
So from the electron to the nucleus of the other
How many
atom, and then
means one attraction,
yes, sir.
second electron, third,
Three
and
and
four. Got it now? There are
yes, sir.
four attractive forces.
Yes, sir.
There are four attractive forces.
Portion.
Okay. Can you count the number of the repulsive forces that may be there?
Two of them. Nine. One, two, three, four. Repulsive forces will also be just a second. Mhm.
Can you count the number of repulsive forces here?
Yes, sir. So the nucleus to nucleus, that would be one. Then
One,
one electron to
two,
the
three,
three, and then four and five.
4, and 5. 5 repulsive forces are there.
Yes, sir.
And due to this, what will happen? The repulsive force dominates.
Yes, sir.
Repulsive forces dominates.
Dominant.
Right?
Yes, sir.
And that is why helium molecule does not exist.
Yes, sir.
Helium molecule does not exist. Am I clear till now?
Yes, sir. Yes, sir.
Okay. Now next write down valence bond theory. Valence bond theory. Valence bond theory.
Sure.
According to this valence bond theory, only the unpaired electrons, only the unpaired electrons which are present in the outermost shell, their orbital overlapping takes place. Their orbital overlapping takes place.
Mm.
And that leads to the bond formation.
Okay.
That leads to the bond formation called as a sigma bond, called as a covalent bond. Let us explain with example now. Suppose I had explained the H2 molecule.
Yes, sir.
Suppose I need to explain the H2 molecule. Hydrogen atom, atomic number 1,
Yes, sir.
electronic configuration is 1s1.
Yes, sir.
Rupashi, you know how to represent such type of orbital picture electronic configuration? Yes, Rupashi, can you hear me?
Yes, sir.
So, second hydrogen atom. This is the electronic configuration, but now I'm showing here
Downward spin.
by this,
Yes, sir.
right, opposite spin. These are the
Yes, sir.
unpaired electrons which are present in the outermost shell, and their overlapping takes place here. And the bond is formed between the two, single bond. Understood?
Yes, sir.
Understood or not?
Yes, sir. Got it.
So, S orbital, what is the shape of the S orbital? Can you tell me?
Spherical shape.
Spherical shape. So, this is the 1s orbital of one hydrogen atom with the upward spin. Second hydrogen atom, 1s orbital with downward spin. These overlap here head to head. The unpaired electrons lies in between the two and form a sigma bond.
Okay.
Got it? Got it now? What is sigma
Yes.
bond? Right?
Yes, sir.
Okay. Now, let us take up an F2 molecule. Fluorine. Atomic number 9.
9.
Electronic configuration 1s2, 2s2, and 2p5. It has a one unpaired electron. One
Yes, sir.
unpaired electron. Got it?
Yes.
Second fluorine atom. Also the same electronic configuration.
But with downward spin.
1s2, 2s2, so there these unpaired electron take part in bonding, right?
Yes, sir.
So
Yes, sir.
F single bond F bond is formed.
Yes, sir.
And now you can see in the outermost shell I have a 2s and 2p. These are three pair of electrons which are present in the outermost shell but they do not take part in bonding.
Hmm.
These are known as a lone pair of electrons and this is called as a bond pair of electrons.
Okay.
Understood?
Yes, sir.
Wait. Now let us do some question practice,
Yes, sir.
right?
O2.
Right.
Non-metals. 1, 2, and 3 first. No, 2, 4, 6.
What is this?
How is it? By
Single
electron
bond,
pairs.
double bond formed by sharing of 1, 2, 3 electron pairs or 2, 4, 6 electrons. Then it will be right.
Yes. Yes. Triple bond.
Good. Limitations we have done already, right?
Yes, sir.
Let's talk about the formal charge now. Total number of valence electrons in the free atom minus the number of the non-bonding electron as a lone pair minus half of the number of the bond pair of electrons. Half of the total number of the bond pair of electrons. Note down the formula, then we apply it.
Yes, sir.
Formula of the ozone, right? In this ozone, I have 3 oxygen atoms. Let us calculate the formal charge on oxygen atom number 1. According to the formula, the total number of valence electrons are 6.
Yes, sir.
The lone pair electrons are 4 in number. Can you check here?
Yes, sir. Yes,
And
sir. 1 to 3.
and half of the electrons which are involved in the bond pairs 1, 2, 3, 4.
Yes, sir.
So that is equal to now 0.
Okay.
Can you calculate for the oxygen second?
Yes, sir. FC is 1. 1.
1,
Yes, sir.
6, 2 electrons, half of this is equal to 1, right? Calculate for the third.
Yes, sir. Minus 1.
Good. 6, 6, half. Got it now?
Yes.
Now, leave this part. Calculate the formal charge on the carbon.
Yes. Check. 0.
0. 4 minus lone pair are 0. Bonding 8 electrons. 0.
Yes.
Okay. Double bonded oxygen atom.
0.
0. 6. 4 electrons. Half of the 4. 0. Okay. Single bonded oxygen atom.
Minus 1.
6 minus 4. Okay, minus 1. Got it now?
Yes.
This is the nitrate ion structure. Formal charge on
Yes.
the nitrogen.
0.
5 valence electrons, 2 are the lone pair, and 6 half 0. Okay, on the double bonded oxygen atom.
0.
6 minus 4, half of the 4, 0. Okay, single bonded oxygen atoms.
-1.
Minus 1. Good. Work upon this question.
9, 10.
Repeat, please.
10.
10. Yeah.
Can you calculate the one for this?
Sulfur, sulfuric acid structure, you remember it like this.
Okay,
So the valence electrons are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
yes. Yes. 0.
0. Good. Go for this question.
1.
Yes. Okay. Ionic bond we have done already. Hmm. Properties we have done. Can you answer this question?
Because in this, again, we did it yesterday. It's an electrolyte. So in the solids, it conducts in the liquid state and does not conduct in
Hmm.
the
In the solid state, these ions are not free.
not free.
They're bound
Yes.
with each other, right? Rupashi, tomorrow morning class at 8 o'clock.
Okay, so
The timetable that I have sent to you, right?
yes, sir.
See, this silver nitrate
Hmm.
in the aqueous medium will dissociate like this.
Yes, sir.
And sodium chloride also dissociate like this.
Yes,
When
sir.
they add the two, their ions will be exchanged between the two, silver
Yes,
chloride and sodium nitrate. We don't need to
yes.
break any bond, right?
Hmm.
But in case of the carbon tetrachloride, this is a covalent bond,
Yes, sir.
and sodium chloride is an ionic compound.
Yes, sir.
So here, bond formation, they are not ionic. They will not even dissolve with each other.
Yes, sir.
That is why it will not make any reaction here, right?
Yes.
Right, Rubashi? So
Yes, sir.
that's all for now, and see you tomorrow morning at 8. Right? If you find any difficulty or if you find any doubt, just ask me in our next class. Right?
Okay.
Class was useful for you?
Yes, sir.
Yes, you learned. Okay. Practice all this by writing.
Yes, sir.
Right? Okay then. See
Thank
you
you, sir.
tomorrow.